So let's go over the parts here. First we have the Quantum Venture Copter frame. I got this for about $45 on eBay. And you should be able to find it between, I think, as low as 35, as high as 50. But usually 40 is about a good number for purchase. And then the DJI flight controller. And it also includes the GPS, and this is actually a GPS antenna. There's a number of parts that go in there, including the flight controller connector, and there's a few other peripherals that go with that, and we'll cover that later on. Then we also have the Fat Shark teleporter. This is the V5. So that's the Fat Shark symbol there. So that gives you the first-person viewer set, and that should come with its own camera. Then we also have the Turnigy Multi-Star Outrunner motors, and so you get 4 of them. And if you see on the box there, they look just like that. Now here's something really interesting, and I'll show it to you when I get ready to put together. But there is an offset pattern with the screws for that particular motor. And what winds up happening here is if you get the wrong kind of motor, it won't sit in correctly. So just make sure that the numbers match the particular model number frame kit. And we'll cover that here in a second. And then we have the ESCs. They have ones that are a lot wider than this one. I decided to get the slim ones because of the availability, and wanted to see if I could reduce weight to increase speed and longevity for battery power. So I got 4 of these. It really doesn't matter what kind you get as long as they're 20 amps. Okay, so just remember that. So you can adjust those how you see fit. And then move off over here, and you have some propellers. Or I should say the rotor blades. It's probably a good idea to buy 2 sets, because if you're learning how to fly these things and it's the first time, you might want to crash in it, and those usually are the first things to break off. And then you also need, there it is, 14 gauge wire, because you're going to have to extend some of the connectors. And then we also have the Spectrum DX6i controller. And so you're probably wondering, like, so what do I need to get with this DX6i controller? Really all you need, believe it or not, is just the controller and then the rechargeable batteries that go with it. So how do you connect it to your quadcopter? Now, granted, some models will come with the connections with the receiver sets. You'll be able to plug it in directly that way. Or you could use the ever popular, and here it is right there. That's the orange R615X, or the orange RX. And that's very popular. And the way that you connect this, or I should say bind it with that, is you have this binding wire clip, and we'll walk through how to do that as well when we hook it up to the when we hook this up to the controller, and then we hook this up to the receiver. Well, actually, this is the receiver set, and then this controller here. Then we also have a few other peripherals. One, you have the battery. I guess I can take it out so you know what it looks like. It's a lithium polymer battery, and that's standard for quadcopters that they all use. The lithium polymer set batteries. Let me just dump that out so you can see what it looks like. There we go. And you're looking at 2,200 milliamps, so somewhere around there you should be good. And I shouldn't have dropped it like that, because they're actually slightly volatile if you don't take care of it very well. But usually when these get shipped off, they're at half voltage. And then I almost overlooked the ESC programmer chipset, or I should say programming card. And then for the Fat Shark, you want to be able to have a micro SD card. That'll give you, let's see, I think I doubled it. This is an 8 gigabyte. If you get about 4 gigabytes, it'll give you about an hour's worth of video. If you get 8, it'll double it. And I think that's pretty much, oh, and these are the bullet clips. And these here, you got about 20, let's see, I think you need about 20 male and female connector sets. and that'll be used to extend the wires. That's why we got the 14 gauge wire over there. That'll be used to extend the wires that lead from the quadcopter to the controller sets. And then you also have the 10, well, I guess it's the 10 gauge or 10, so yeah, 10 gauge male-to-male servo leads, and that's also to extend certain wire sets, which we'll cover later on. And I think that's about it for the inventories. And like I said, I got most of the stuff, 90% of it on Amazon and eBay, and also Hobby King. And I'll leave those websites down at the web page. And there were a few where I actually had to go out because Hobby King ran out, and then as well as Amazon and eBay. So I went to two other companies I really wasn't too sure about, but it worked out anyway. Let's see if I can find the name of it here. Oh yeah, one of them was Fiber Optic Products, and another one was like Flying High something or another. But I'll leave the websites there at the bottom. Okay, first thing we're going to do is establish the inner frame. So you get this piece here, and then line it up with the opening on the one pole there. And make sure the holes line up, and then use the Loctite fluid. You only need a little bit because it's kind of like a glue, but it takes a while for it to harden up. And just line it up and turn the screw in, and there's one. I think I left that in there a little bit too long, but that's okay. And then we'll do the second one. Put just a little bit of Loctite on that. Like I said, it doesn't take too much. And just make sure, and I like to do this here pretty much hand tight. And the only reason why is if you're putting Loctite on there, it'll set in like a glue almost. The nice thing though is if you do mess up and you have to take it apart, you could still do that as well. Okay, so that's that. And let's see here, I already slid this one on, so I've got one more screw to put on with that one. I'll take a few seconds. Oh, that's a little bit too much, but be careful with that. And line it up with the hole and put it in. There you have it. Okay, and then as I said before, there are 4 screws here, and when you mount this, you want to make sure it's free spinning, it's not rubbing up against any plastic. It's pretty straightforward. And like I said before, I mounted it upside down because it was offset. Hopefully when you get your kit, it won't be, the offset will be reversed, so you can be able to mount the motor up on the other side. But I think I can get away with it. You just have to put the screw in on the bottom and just reverse it, but it should be fine this way. But we'll see. Alright, next thing we'll do is, you see how I put these bullet connectors in here. I'm going to do some soldering. Okay, so what we're going to do is finish the extenders. And so what I mean by extenders is we need to extend the wires for the Turnigy motors. So you take the bullet connector, drill some holes into a piece of wood, and then you can drop the ends in, and then just melt your solder on the inside, just like that. Looks like I got some extra stuff in there. That's okay. And then as it's melted, back it out. Wait a couple seconds and pull it out, and there you go. And if you want, you can take the excess solder off. There you go. Take a little bit more of that off of there. And ideally, and I wanted to do two times because I wanted to show you that I put my shrink wrap on this one. My shrink wrap's big enough where I can put it over top of everything, but if you get smaller kind of shrink wrap, then you may have to put that on first before you actually do both sides. So we'll do one more time. Melt the solder on the inside. until it just about fills up. And then, as you see it liquefy, back it out. And as you back it out, there we go. Wait about 3-4 seconds, and comes right out. Too easy, right? Now you give it a shot, do it 12 times, both sides, and shouldn't take you too long. Okay, so then the next thing we're going to do is melt the shrink wrap. I'll just show you real quick. So all you want to do is just make it right to the line of the bullet connector. Make sure I'm in the camera right to the line of the bullet connector. On this one, the other end, on the female end, the receiving end, it should be just about flush. So you put it on. Should take about maybe 10 seconds, if that, to melt it through. Make sure you all can see that pretty well. And looks pretty good there. Flip around to the other side. And pretty much there as well. And that'll help reinforce the hole that you have with your solder. So, there you go. Do that 12 times and then we're ready for the next part. Okay, so now we're going to attach the motors to the frame. And I've already got one side done, so I'll just show you real quick. It's real easy because we made the extenders. You just push the bullet connector through, and then if you get lucky, maybe you'll angle it up. Otherwise, just use a screwdriver or something to be able to pull that, pry it up. Just try to do like one at a time. Don't shove all three of them in there. And they should go. First two are always easy. It's always the last one that gets you. You know, so you kind of have to dig to get them up and out of there. Yep, there's the second one. And actually, I could use needle nose too to get in there to get that, but it's too lazy to go downstairs and get my needle nose pliers from the toolbox, so I'll just do it this way. And there's the second one. And then I'll go for the last one. There it is. So roll that guy up. A little bit. There we go. Just pull the rest of them through. And make sure your orientation's right. Lost the hole. You're going to line it back up. And there you have it. So then just drop your screws in and then attach your center bar, and we'll move on to the next step. Okay, there's one thing I wanted to show you real quick. So when you put the screw in, you know, to tighten the motor mounts to the frame, one thing that I noticed is as you line it up to push it through, and you remember also because I put these in upside down backwards, I should say, this part right here would have been down on the bottom, and I would put the screws in on the top, but putting it on the bottom. And what you want to do is don't put the Loctite on the screw itself. You want to put it in on this. Just add like 1 or 2 drops from there, just so it seeps down in there. And the reason why is because if you put it on the screw itself, and as you push it through, the wires could wipe a good portion of it off, and then it gets sticky on the inside as well when it dries. And after that, just go ahead and tighten it up. And like I said before, it's good to do it by hand because these are plastic pieces and they're very easy. Well, I should say very easy, but you can always break plastic a lot easier if you're utilizing like an electric screwdriver or something. So that's in there, and there you go. Okay, so the next thing I want to talk about are the landing legs. They're very easy to put in. There's just 2 screws, one here and one to the right, so left and right side. And then make sure that each landing leg is pointing toward the center of the frame. And so there's that one, and then there's the other one there, and then the one on this side, and the one on that one. I would just do it, but it only took a couple seconds, so shouldn't be too hard to do. And then I went ahead and just added the camera holder frame, so you just slip it in on the top and then just put short screws in there. Let me just finish tightening this up here. And strongly recommend just hand tightening. You don't want to use an electric screwdriver because this is all plastic and it's very easy to break. Alright, now we'll move on to the next piece, which would be the soldering of the circuit board. Okay, so the next step is to solder the ferrite beads to the circuit board. So you're going to solder them to the bottom of the circuit board. How do you tell what's the bottom and top of the circuit board? Well, if you look closely, right here you see the name Hectronics on there. So what that means is that's the top of the circuit board. So you're going to solder most of the pieces here on the bottom because you're going to be mounting a lot of stuff here on the top. And what I mean by that is like the battery sits on the top, so most of the major components will be on the reverse side. So I've already bent one and then put it in. So I'll do the same thing with the other one. You just match it up, just figure out where you have to do the bend. And just line it up. And the nice thing is they're not polarized, so it doesn't matter what direction you actually have them placed. There we go. And then what I'll do is I'm going to solder these positions first, and then I'll clip them. That way you still have a little bit to play with. Okay, so for soldering, you might notice that depending on what type of solder you use, is 2 kinds here. I have this one here, which is a little bit thinner, and I think this is the 0.79 centimeter, 0.079 centimeter in diameter. And I would recommend utilizing thin solder material instead of the thick stuff. And that's what I was using initially. The reason why with thin, you can shove it through the holes and you can melt it in between. It'll hold better. And let me finish up this last bead right here for the FPV connector. I'll give it a second. And I have one of the adjustable solders, and that can adjust the heat level. And with that, there we go. And there's the beads right there. And as you can see, they're pretty solid. They don't move around. And because I shoved it all the way through, it's got a good connection up here at the top. And actually, I think I'll just drop 2 beads up at the top as well, just to ensure the connection. Make sure I'm still on the camera here. And then I get it right there. And sometimes if you have it on high heat, it'll melt quicker, but at the same time, the lower heat, you can tend to manipulate it a little bit easier. But you know, it's trial and error in how you want to do it. There we go. Ooh. Made a double bead there. Don't want that. There we go. There's one. And let's see if I can get the second one in without connecting to the other one. I might block the camera a little bit, but I'll just see it after I'm done. And voila, here we go. And you see the little beads right there. And the wires are pretty solid, they don't move. So now we can move on to the next step. Okay, and we're going to continue to make the power cable here. I've already soldered in one side, just so you can see that. And then I'll do the other side. So basically the same way we did with the bullet connectors again. So just heat up the one side. Try to stay in the area of the camera so you can see it. Maybe I can zoom in a little more so you can see it. There we go. So heat up that one side and then drop your solder in there. Should be okay. And heat it up one more time. Essentially liquefies. And that should do it. Yep, there you go. And the one thing I want to show you is that the black side should be on the pointed end, and the red side on the flat end. So we'll put some shrink wrap on there and then go to the next thing. One thing I want to show you how to do, I don't think I showed you how to do this earlier, is called tinning the cables. So if you take solder, this thin solder, since that's the kind I'm using now, and you just wrap it around the wire itself. And actually, that's probably a lot right there. Don't need that much. And take the rest of that off of there. There we go. And so the intent is to melt the solder on the wire so it basically tins the entire exposed wire. So when you wrap it around like that and take your soldering iron, see how it melts itself into the wire itself. See that? And so now, when we get ready to solder it onto the board, you'll see the positive and negative positions there. All we should have to do is just heat that up and get it right on there. There's one. I'll do the same with the other one. Make sure I'm still on the camera there. Heat it up. Make sure you mind the positive and negative position markings, so you know, so you don't get your sides mixed up. There we go. Now they're both stuck on there, and then you can just add a little bit more solder to it just to finish it off. That way you can kind of melt it right in there. There we go. Now, let me see if I'll zoom in a little closer so you can see. So I'll do the same thing. looks pretty good. Let me do the back side here. Make sure you all can see that. There we go. Why don't you see that? And I'm going to zoom back out just a little bit. Just to get the back side. I'll get the back side of this one. There we go. A lot of times I just tell you to do stuff and think you know how to do it, but I wanted to make sure you all understood. And you see, it's already in there. You can flex it and everything like that. It's on there really good. One other thing I wanted to show you was the these are the power cables, that we're going to plug what I call the GPS NASA controller into. Instead of soldering it to the board, we just made these connectors. So that way, if you ever wanted to replace it, you can do that. So all I did was just put the bullet connector on there, just cut about 1.5 inches of wire, and then same way I showed you how to do the bullet connectors before, just link it in there, both of them black and white. Well, I should say red and black, and then just shrink fit it on there, and then you'll be good to go. And we'll go ahead and solder that into the board next. Okay, I'm going to continue to make some more bullet connectors. We're going to use this for our ESCs because one of the directions I was looking at, that came with the quadcopter frame, was that you're supposed to clip them and then glue the ESCs directly into the circuit board. And when I looked at some other techniques I saw online, some other folks said, hey, it's better to make the bullet connectors, so that way if you want to change out your ESCs, because the way technology is evolving within the quadcopter family of vehicles, flight vehicles per se, you never know if there's going to be an improvement to these ESCs, or if they have a better way to distribute power. So I always want to have a build with what we like to say with open architecture. In other words, ability to be able to change and upgrade, modify. And as you can see, very easily, once you get the technique down, it only takes you a couple seconds to melt the solder into the bullet connectors. You saw me do this before earlier. I'm just cranking them out. There you go. That one I'll let bend a little bit. Maybe I don't like kind of left's kind of straight. Well, actually it'll be okay because it's going to be laying down. So. Okay, and I'm going to mount the last ESC. Just did all the other ones, but I'll show you how to do it real quick. I like to plug these in first, and you remember how I soldered them to lay flat. Turn it over, and just so the cables these are the cables that'll connect up to the Turnigy motors there. So what I'm going to do is I'm actually going to bend this down and back out again, so that way the wires for the motor are long enough to connect, and the little bend should be okay. And then put a zip tie around the top part of this. Just feed it through here and right there, and we can cinch it down and make sure everything's in place before we put the last tightening pull on there. Make sure you all can see that. Looks pretty good up top here. And since we already soldered it down, it's just kind of keeping these in place. And just cinch it just a little bit more. Don't have to cinch it down too much, just so long as it doesn't move and break loose, which it won't. And take your wire cutters and just crimp off the end. There we go. And so now you got your leads pointing out in the direction of the motors. And then the circuit board's pretty much done there. Now we just have to mount it onto the frame. Okay, now we're going to mount the board. And before we do, I'm going to put some electrical tape across the top here. And you may ask why, and the reason is I read somewhere that, you know, with these kind of boards here, you never know, and that you could actually short the circuit board when you have that metal connection onto the PCB board. Even though I don't really see on the board where it could do that, but to be on the safe side, we'll just go ahead and do that. So when you mount it, you just got to find out where the holes are. You have to lift the tape up probably. Find the other one. There it is. And then there's the other one. It's just to be safe. You don't have to do it if you don't want to. Might still work just fine. But I always like to not take too many chances. And then just grab the board. Make sure nothing's pinched or caught up under it. Pretty straightforward there. The wire's set. And line the holes up. Now the other thing you want to do too, we haven't done this in a little bit, thread locking compound. Definitely want to use it here. So we'll put a little bit of that on there. I have the right tip on here. I'll have to double check that in a second. Yeah, I think I have my larger tip. Let me change that out. Double check it. Yeah, it's the right one. I'll just line that up. Like I said before, you definitely don't want to torque things down using an electric screwdriver. Just hand tight is all you need, and the thread locking compound is very effective because I did actually try to undo one of the connections a while ago, and it was very difficult to get it out. So the thread locking compound works just fine, so no worries there. So just get it down there to hand tight. Like I said, you don't want to tighten it too much where you crack the board. And then we have the third one. You trying to get in there right now? There we go. Look like it's stripping. Huh. It's interesting. Tighten that up. Okay. Now we're done. Okay, the next thing we're going to do is install a camera. So here's the foam frame, and there's double-sided tape on the inside. Make sure you peel the top layer out, and then what you're going to do is figure out the orientation of your camera. So this would be facing the correct way. See that? And this is Fat Shark on that side there. So feed the cable through this opening here. It's pretty straightforward, right? And make sure the Fat Shark's standing up, and just push it all the way through. Just like that, and then drop it into the front like this. Then you just need to drop this on there. I already had the screws pre-positioned here. Make sure I got the, whoop, not to drop these guys again. Did drop just one, and just fit that on there. And these are the small Phillips screws, so we just add those in there. There we go. Get it positioned and then work it down. And like I said, something happens to the camera, you may want to be able to change it out. So some people put Loctite on there, some don't. I'm not going to use Loctite. But make sure you keep the cap on your lens for your camera as well. All right, pretty straightforward there. Now the next step. All right, there's one more thing I almost forgot to do. You remember when we put these two bullet connectors there? In the future, we were planning to actually connect instead of solder the power modules leads, so that way you can change them out in the future. So now we got to make up for that and go ahead and get these bullet connectors squared up. I'll give it a second. That one looks pretty good. There's one. I did the black one. Well, actually, I just blew off my shrink wrap too. Got to do that in a second. Almost there. Keep it hot. Probably could put more solder in that one. There we go, much better looking. Alright, take that down. I think that's the only last of the soldering I need to do there, and then we'll go ahead and add the shrink wraps on there, and then we can plug it in. And remember, these are the male bullet connectors, so you don't need to pull it all up like you did with the female ones. See, so it's just short of that. And I got another one somewhere that blew off by accident. And let's see, I'll push that through. Get a little tight. A little bit further. All right, and we'll just go ahead and shrink wrap those tight and we'll be done. Okay, so we're going to wire the orange RX receiver to the NASA flight controller. So we'll start off with the top here. For auxiliary 1 is going to go to X1, which is the gimbal pitch control, and it's right here. And as you can see, it's a yellow wire on the top, and then when you get it here, the brown wire is on the top. Let me see, let me move this wire out of the way. And so it'll be inverted. So what you have on top here will be inverted, so the yellow wire is here on the bottom. Alright, so we'll go to the next one here. So next one is gear. And so gear is going to go to U, which is the letter U right down here. And that's for the flight mode. And then you go to RUD, which is the rudder. And there's an R right here, so pretty straightforward there. Then the next one is going to be elevator, which is right here, E-L-E-V. And then, of course, what do you think? The letter E down here. And then we'll go to the Alerion, which is the A-I-L-E, which is right here. And that'll match up with the letter A up here. And then the next one is the throttle, which is T-H-R-D. And that'll match up with the letter T right here for throttle. So that's how you do those two. And then, of course, you then put in your LED. You can see at the very top here, LED and EXP. So I'm going to put the LED, just plug it right in on the top. Actually, I think I have it inverted there. There we go. Slides right in there real easy. Okay, so now we'll go ahead and program the ESCs. Also fairly straightforward. If I can move this out the way. There we go. So what you want to do is you want to find the power module that's going to go to the NASA flight controller. Just plug that directly into the ESC side. Actually, I'm going to flip it over here because all the words and everything are on this side. And I'll zoom it in so you can see a little bit better. There we go. So right here you see the positive and negative, and that let's make sure I got that. Yeah, so the positive and negative, which is coming from the power module right here, and it says ground and the 3 volts and then the VSEN. So just match it up just like that, and you see how the red is in the middle and then the brown is on the bottom. All right, and on this right side is where you plug in the ESC control set. So as an input here on the top, and the brown is here, the negative on the bottom. And then the jumper cables is what actually does the settings. So we have lithium polymer batteries. So we pick Li and then XX. We're set to medium for the cutoff voltage, and then we're set to slow down for your cutoff type for rotation. Why are we doing that? Well, if your battery runs low, then you can either tell the motors to stop spinning completely, or you can tell it to do a slow spin so it gradually comes down out of the sky, so that way it doesn't fall out of the sky. And that's where it comes to your brake. So ideally your brake should be off. If you had it on medium or hard, it would just stop and it would just cut off completely. But here you can either do like a free spin or a power down spin. And then we have timing. We have that set to auto, and start up would be medium. You know, if you put on high, it might burn a little bit more electricity and start up quicker, or you put on low or take its time. I put it right in the middle there for medium. And that's the ideal set for energy conservation. So now what we need to do is plug in the lithium polymer battery. Okay, so now we're going to go ahead and program each of the electronic speed controllers. And just so you remember, we have to take the input of the ESC, where the yellow wire is on top, where it says input, and the brown wire is on the bottom. It even says brown in parentheses, which is really nice. Maybe let me zoom that in there a little bit so you can see better. And then for the power, you take the NASA power distribution module, and then you plug that in. Red wire should be in the middle, brown, which is negative, should be on the bottom right there. So now all we do is just plug in our lithium polymer battery. I'll zoom back out so you can see it. All right, we plug that in. We should hear 2 series of beeps, like a doo-doo-doop, doo-doo-doop. Let's see here. There we go. And so you do that all 4 times. So we'll go ahead and switch them out for each ESC. And if you listen closely, they're coming from each of the motors. So that way you know if which motor is which one. All right, we'll do it again. There we go. 2 more to go. Do this front one over here. Make sure yellow's on top. There we go. I was a little muffled, but I heard that one. And let's see, the last one will be this guy. Let's see, yellow on top. All right, plug it in. That was weird. I'll do that again. There we go. So all of them are programmed in correctly. So now all we got to do is connect the power wire that we just took off. Well, that's the ESC here. Make sure I get them all lined up correctly. So the power wire we just took off now goes into the position of X3 on the NASA flight controller. So we can go ahead and plug that in now. And then just like all the other wires, the brown wire should be on top, red, yellow wire on the bottom. So we'll go ahead and feed that in there. Make sure there's a gap so we know it's an X3. Perfect fit. I already plugged the LED in. So now all we got to do is plug in each of the flight control ESCs. Well, plug the ESCs into the flight controller. So I'm just trying to figure out which way I want this wire to roll. I guess I can move around a little bit. So as you remember, each ESC, like this would be, let's see, if you flip it back around, each of the positions, like we said, position 1 was here, 2, 3, 4, like that. So if you said that's 1, this is position 1 here. All right.
So position 1, and these are position 1's wires going this way. It tucks in this way. And so this should be the number 1 ESC. And I'm going to take that and put it into M1, making sure that, there we go. So we'll connect the first ESC, and remember this time here that the yellow wire will be on the bottom, just like all the other connections here. So that yellow wire ESC goes into position 1 for M1. This is number 2. Yellow wire at the bottom, brown wire at the top. Position 2. And this should be 3. Looks like it's in right. And last would be number 4. There we go. And as you can see, you have M5, 6. So you can do a copter with 6 positions, or you can even double them up and make it 8, I believe, is what I was told. But ideally, we're just using 4. And then what we'll do is connect the GPS controller wire, and that'll go right where it says EXP at. I think that's inverted. Well, actually, I was right the first time. No, I was right the first time. That was inverted. There we go. Too easy. And move on to the next step. Okay, I want to show you guys the first-person viewer camera set here. This is the transmitter set from the Fat Shark. And all you have to do is just press it down here with some 2-sided tape, and then stick it through there. Now there's a problem with this one. If you buy this kind here, you're not able to actually shove this antenna through there because it doesn't disconnect. So if you see, I actually had to cut around there, pop this off, and then cut here all the way to the top, and then actually compress the metal antenna pieces so I could shove it through this hole here. So I had to do some modifications. So try to stay away from this kind of receiver. Oh, I'm sorry, this is the transmitter set here. All right, so from there, this is the one power cable that you can either hook up directly to, but this one actually comes with a noise filter set right here. So there's a capacitor and everything like that. So you go through here, and it's supposed to be able to filter out some of the excess noise or humming noise that comes from some of the motors or the battery. And then from there, you just plug in the camera cable up on this position here, and then you plug in the battery cable here. Now, there's another way you could do it too. You could bypass that and just plug it in directly from there as well. Okay, we're going to go ahead and go through the binding process. And one thing that you need to know that's very unique about the binding process is, as most quadcopters operate off of 2.4 gigahertz, how are you able to make that unique to your particular transmitter? So I have the, it's kind of blown up here, Spectrum DX6i, and so I'm using the Orange RX transmitter. So I'm going to zoom in just a little bit more. And so now I have this binding clip. You see it's got like a little jumper cable type thing. And I'm going to need to put it on the back end, but sometimes it won't fit, so you just have to pull out the bottom cable, which I think in that case is the, I believe that's the throttle set. And then make sure that when you put your binding clip in, that it goes on the last 2 prongs that are in there, and I can see it, so I know I'm lined up in there. All right, then the next thing you got to do is make sure the power is off first before you even go through this process. Now that I have the binding clip in, now I can connect the battery power to it. So I'm going to zoom back out. You can see it a little bit better. So now I'm going to connect the battery power, and then, there it is. We should have, there we go. And so it's blinking orange. So when you see this orange blinking like that constantly, it's telling you that it's lost connection to the receiver. And on top of that, the LED on the bottom is blinking red. It's going to stay like that until we get to the until we actually bind the transmitter set to it. So now you take your DXI transmitter. Remember, the receiver is still blinking orange. Take your transmitter. Don't turn it on yet. There's this, what do we call this here? A trainer switch. And so you push the trainer switch up towards you. They call it the up position. And then you turn it on. So we'll go ahead and turn it on. You give it a second. And now it's got a steady blink. Do you see that? And when it did that steady blink, that means it's already hooked up. So I can let go. And you can leave the transmitter on for safety reasons whenever you got power. So just remember, and of course now you see it's a steady orange, is not blinking anymore. All right, so that's a good thing. So now we're going to go through some other steps here to get everything synchronized. So keep the binding plug around all the time, because you never know which you'll have to bind next, or whatever systems you want to add to it. So now all we have to do is power it down. And then the other thing I want you to remind you of too is you never want to, and notice I didn't put the rotor blades on or anything like that, but you never want to power your quadcopter without the transmitter being on. Okay? Okay. Made a few modifications to the aircraft. I took off the bottom landing gears, and I put in this new extension one here because I'm thinking about putting a camera gimbal on the bottom. Alright, so just a few more things just to remember. One, after you've put your base down on the quadcopter set, then you're going to have to assemble this here. Don't forget to add in the GPS antenna. Real easy to do, it just mounts right up in the top there, and you just feed the wire through, and then you connect it to the receiver set. Then you just have these screws on each side there, and then one at the front that you'd have to bolt in. Alright, so now what we'll do is we'll connect the battery. Now, I'm not going to fly this in the house, but I'm going to show you a few things that took me a while to figure out until I searched the web and figured these things out. So first thing I'm going to do is attach my first person viewer camera power supply, and that'll go in there. I tried to use 3M tape on that one there, and it didn't work out. I have to do it manually here. Let's sit in there a little bit better. There we go. Whoa, it popped out. Do it one more time. Here we go. Now it's in there. And then we just attach the power supply. Actually, before you do that, you always want to turn your receiver on first. So I'm going to turn, your transmitter on first. So I'll turn that on first. And I already programmed it. I'll probably have to make another video how you program these. There's a few out there already that probably are pretty good on the web. So we'll plug that in. There we go. And I'm going to move this out the way for a second. So the last two things you got to do is you got to put on the front panel. So this feeds in and attaches on the front like that. And then what keeps it all together is this piece right here, which goes over top of the camera, actually over on front. Fits right in there. Now everything's pretty much stable. Pull that in just a little bit more. Alright. Now there's one other thing I want to show you. If you were going to fly this thing, and it took me a long time to figure this out. So on the web, they talked about how when you get ready to fly, you see I'm moving these controllers here and nothing's happening, right? So what you have to do is you actually have to arm your quadcopter. And on the web, depending on where you're looking, somebody tells you to push it up in the left corner or whatever else. But I will tell you the right way for this particular setup is this. You pull them both down on the inside like that. You see, now it's on. And I'm not going to accelerate it because they'll shut off after a few seconds. If I had pushed up the throttle, then it would have increased. So I'll do that again. You push them both in the inside like that. You see? And then if I wanted to, I could increase the throttle, but I'm not going to do that. All right? And good luck with your assembly.